let's start with the introduction of what is continuity. All right. See, whenever we talk about this continuity, so see this continue. So any function which is continuous, isn't it? So continuity. So whenever we talk about this one, the continuity part, you have some function. Say, let's call that function as f of x. So you have a function f of x, and is that function continuous? See, in the mathematics part, in math, continuity plays a very important part because if the function is continuous or not. Now, depending on that, we have a lot of parameters which works on that one. For example, we can talk about is the function differentiable, or most of the things whatever is related in calculus, we have to first think about, okay, so is it continuous or not? All right. Now, whenever we talk about continuity, see, we have a function f of x. All right. Let's take an example, simple example, say sin x. Say sin x. Now, when we have this function, let's draw the graph of sin x. So, you all know the function of sin x, the graph of sin x, isn't it? Suppose if this is the case, then you have a function like this on this side, and you also are going to have a function like this on the other side. So, what we have is a function y is equal to sin x. Now, we look at one single point. All right, one single point. Let's say we look at a point, say 3 pi by 4. All right, some point 3 pi by 4. We are not looking at the entire sine function, we are looking at just one particular point. So we say that the function is continuous. We have to specify where it is continuous, or is it continuous or not. That's why we talk about continuity of a function at a particular point. So here, if you substitute this value 3 pi by 4 in the place of x, that means f of x is equal to sin x. Now take x is equal to 3 pi by 4. So you get sine of 3 pi by 4. Now sine 3 pi by 4, we are going to get a value of 1 by root 2. Isn't it? So the function has a definite value at this particular point. Now last year when you learnt about limits, remember you had left hand limit, right hand limit, and limit at a point. If all three of them they are coinciding, then we used to tell that yes, the limit exists at that particular point, isn't it? Likewise, the function is continuous at a particular point if it is continuous on both left hand side and right hand side. Okay, but we don't call it as left hand continuity, right hand continuity. No, we don't call that. But the final end result is what? Is it continuous at this particular point or not? Now, this is one type of continuity. Now, not every function will be continuous at a given point. Let me show you another example. See, in this example, we'll talk about the function f of x is equal to 1 by x. A simple example. Now, if you draw the graph of this one, see the graph, one part is going to go like this, something like this. And the same thing on this side also. You are going to have a graph something like this. I mean, it's both of them are asymptotes, but anyway. Now here, suppose if I take a point x is equal to 0. Of course, you cannot take x as 0. Because when we define this, we always say x is not equal to 0. 1 by 0 can never be defined, isn't it? Now in this case, here we cannot say it. Suppose if I have a value, is my function continuous at x is equal to 0? Is it possible? No, it's not possible. So in this case, it's not possible. I can give you a lot more examples also. A lot of examples. Like simple examples are signum functions or greatest integer function, least integer function. These are all different types of functions which can be or may not be continuous at a particular point. Understood? Now, this is one type of continuity. That is what we call as the function being continuous at a particular point. Now, the same thing we can say mathematically, you have to define it, correct? So, how we define the continuity of a function is that a function is said to be continuous, or f of x is said to be continuous at x is equal to c if limit as x tending to c f of x is equal to f of c. So this is how we define that a function is continuous at a particular point. Now we can also have function being continuous for the range of values. So what we call is the function is continuous in this particular range. In such cases also we tell that f of x is continuous in the range from a to b. Now it can be open bracket or it can be close bracket, either this one or this one. The function is continuous in this particular range. The same thing, if f of x limit f of x as x tending to c is equal to f of c, where c belongs to a comma b or a comma b. In the sense, you have to check for the values within that particular range, whether the function is continuous or not. So this is basically the concept of continuity. Now, just the concept is not really, very intuitive. We'll look into the different types of examples. Once you know examples and once we solve problem, you will understand the concept of continuity and what we mean by function being continuous. Understood? So in the next video, we'll look into certain rules and algebraic form and rules and regulations of continuity. Then we'll look into certain examples and problems.